what exactly is the difference that we have between the OLTP system and the OLAP system that we have? So you can see here. So basically, OLTP system is nothing but it's a online transactional processing system. So which is basically designed for supporting the transactions that the users are performing. Okay. So when I say transactions, so transactions is nothing but it's a set of DML operations we do. Like we either insert the information. Yes. The time you do the transaction, the system may receive the information, or the system may be updated with the information of the user. Okay. So when you talk about the data warehousing, so data warehousing or the OLAP system both are the same. So data warehouse or the OLAP system is useful for the business analysis, which is nothing but a business processing system. So OLTP always contains the volatile information, whereas data warehouse always it contains the non-volatile information. Means that, so yesterday we have seen once the data entered into the data warehouse will not change the change that is taking place in the OLTP system. And the OLTP always contains the current data, and it data warehouse always contains the historical data. So it's an application oriented system. Based on the application, the OLTP database will be designed. It's an application oriented system, and this is the subject oriented system. Means that according to the subject area that we have, the tables of that the OLAP system will be designed. So means that, so according to the, if you are building a sales, if you are building let us say a data warehouse on sales, that will basically contain only the sales related information. Only the sales related tables are there. So when you are building a data warehouse for finance, that will contain only the finance related tables. Likewise, okay. And the OLTPs are normalized, contain the normalized data. Means that so the normalization technique will be applied on that. Like so the tables are normalized up to the third normal form, whereas a data warehouse is a denormalized in nature. Means that we denormalize the information to the second normal form, okay, and we load the data into the data warehouse. Okay, right, and it is basically useful for the clerical operations. So when I say clerical operations, so when you go for the bank, or if you go for any kind of order entry application, basically the agents or the clerks are going to work on this OLTP system. But when it comes to the data warehouse, the data warehouse or the OLAP system will be used by the business users like managers or the CEOs. Yes, in order to identify the growth of the revenue or identifying the growth of the business and the profits. Yes, the business users are going to work on that. So the functionality of the OLTP is for day-to-day operations. When it comes to the OLAP, it is a decision supporting system where you can take the appropriate and the good decisions upon the OLAP system. So OLTP contains, basically it contains the detailed data, and OLAP contains the aggregated information. Means that when you load the data into the data warehouse, yes, when you load the data into the data warehouse, we basically aggregate the information, we summarize the information, we calculate the total profits, sum of the revenue, right? So we calculate this kind of information and we load into OLAP system. So in the OLTP system, there are many number of users will be present. Okay, more number of users will be present, and when it comes to the data warehouse, less number of users are present. Less users are present. Okay, so here it stores up to 3 to 6 months of data, and here there will be about 1 to 10 years of storage will be there in the database. So more joins are required in order to get the data from the OLTP system, because we have more number of tables in the OLTP. Since the normalization technique is applied here, more number of tables are present and more joins are used. So when the data warehouse, less joins are used here. Okay, so less number of joins are used because less number of tables are present as we are denormalizing. So less indexes are used in the OLTP, and when it comes to the OLAP system, more number of indexes are used. So why more number of indexes is that? Because the main purpose of OLAP system is for allowing the reports to generate. So in order to generate the reports, in order to quickly generate the reports, the tables in the data warehouse should have the indexes. So that is about the data warehouse that we have it. Okay. So the next concept that we are getting is that it's a data mart. So what exactly is a data mart is that? So data mart is nothing but it is something that is derived from the data warehouse. Okay, so data mart is nothing but it's a subset of data warehouse that we have it. So before on the before slide I have said like so when you talk about the data warehouse subject oriented, so subject oriented is nothing but so basically the data in the data warehouse is categorized according to the different subject areas like the sales subject area, finance subject area, yes, marketing subject area, likewise. So in the same way, we can build the data warehouse on a single subject area called as sales, where it contains all the sales related information. We can build a single subject area on the finance where we have the finance related information in that. Okay, so we can build a data warehouse on inventories where it contains only the inventory information. See, whenever you are building a data warehouse on a single subject area where it contains only that subject related information, then that is called as a data mart. So a data mart is basically it's generally small and it is derived from the data warehouse, which is a subject of data warehouse, and it contains the single subject area information. Okay, so we call the data warehouse as an enterprise data warehouse where it contains data across the enterprise. So means that a enterprise data warehouse will have the information about the sales, will have the information about the finance, marketing, HR. So according to, with respect to all subject areas, it will contain the data. But when it comes to the data mart, so data mart basically contains the information only on a single subject area. So if you build a data mart on sales, it contains only the sales subject area data. When you build a data mart on finance, it contains only the finance information in that. So likewise. Okay. So basically when you talk about the architecture that we have in the data warehouse, okay. So when you have the architecture that we have in the data warehouse, let's say that, let's understand. So basically we understood like we have, let us say we have some OLTP systems here. OLTP systems are there. So now we are doing some transactions on this OLTP system. So let us consider we have a banking OLTP system. Okay, so all the core banking related things like crediting the amount, debiting the amount. So all those things we are doing it in the SAP. And with respect to the credit card transactions, so we are doing it on the, let us say, Oracle database. So all the credit card transactions will be done in the Oracle database, and all the insurance related transactions, are done in the let us say mainframes database, mainframes system. Okay, so we are doing let us say we have a SBI bank, State Bank of India. All the core related banking operations are done on SAP, and all the credit card system transactions are done on the Oracle, and all the insurance level transactions are done on the mainframes. Okay, so when we talk about the data warehouse here, you are not going to directly enter the data into the data warehouse. So there are different phases that are present in between the OLTP system and the OLAP system. There are different phases are present between the OLTP system and the OLAP system. So first of all, so the first phase that comes into picture, which is the mandatory phase in the data warehouse, is the staging area. So we have something called as a staging area. So this staging area is nothing but it's a landing area or the parking area where all the raw information, raw data from the OLTPs are stored. Okay, all the raw data is stored here. Means that, so it could be a separate database or it could be a schema that is present in the database. It could be a separate database in a database instance, or it could be a schema in a database. Okay, so the tables, how you are going to identify whether it is a staging table or not. So the tables are prefixed with underscore stg, or the tables may be suffixed with underscore stg. Okay, so what we do is that, so using the Informatica Power Center or using the ETL process that you do in the Informatica Power Center, you are going to, yes, using the Power Center, Informatica Power Center, you are going to extract the information from the OLTP system, and you load the data into the staging area. Okay, so in the staging area, for each table that we have it in the OLTP system, you will be having a separate table in the staging area. So let us say, if you have a table called as employee table here, so you will have a table called as employee underscore stg table here. If you have a table called as customer OLTP table is there. In the same way, you will have a customer underscore stg table. Okay, for each table that exists in the OLTP system, there will be a corresponding table exists in the data staging area in order to load the data in. So all the raw information from these tables will be entered into this staging area. So we are not going to perform any kind of transformation logic here. So the transformation logic is an optional one here. So we extract the information and we load the data into the staging area. So the staging area, the data that you have it in the staging area, it's not permanent, it's a temporary data. It's a temporary data that you have it here. So when I say temporary data, you have it in the staging area, it means that, let us say, on the day when you have some 10 million records in the whole OLTP system, you have it. You are moving the same 10 million records. You are not doing any transformation logic, so you will get the same 10 million records into the OLTP system, and the data is processed from staging area to the OLAP system. You do different transformation logic. You apply different error handling methods and transformation methods, and you load it into the OLAP system. Okay, you aggregate the information and you load it into the OLAP tables. So on the second day, if there are some extra, let us say you have some 5 million records again getting here. 5 million records you are getting here on the day 2. So since the data that is there in the staging tables already processed into the OLAP system, so these old data has to be erased here or deleted here in order to load only the fresh data, that is 5 million records, that has to be processed into the OLAP system. So what do you understand? So when you get the data, fresh data again in the OLTP system, so this data, old data has to be erased here. So that is the reason the data that is called in the staging area is a temporary data. Means what you do, you truncate the information, you truncate the old data, and you load only the new data. So that is the reason it is called as a truncate load. The kind of load that you do it in the staging area is a truncate load. Means you truncate the existing information and you load the new information. Is it clear? You truncate the existing information and you load only the new information into the data. You load the new information into the data staging area. Okay. So any questions so far? Any questions? Nidhi, any questions quickly?
Venkat, what you said the transformation is optional, right?
Correct.
So, like, what exactly is the need for the staging area? Can't it be directly like loaded, or like, I mean
exactly. That's a good question actually. Okay, let me see. So let us say you have an employee table in this core banking application, which is SAP. You have the employee table, employee information, even in this Oracle, credit card in the credit card application also you have the employee information. So let us say if you don't have any assume you don't have the staging area and you are directly processing data into the OLAP system. Okay, so you have to integrate these two tables, employee table and the employee table, from both the OLTP systems so that you have it. But the OLTP system that you have it in the SAP is available from 10:30 p.m. to 11 p.m. You have this in this timing, and you have the connection for this OLTP system at 11 p.m. to 11:30 p.m. So you have the connection for this OLTP system during the different time zones. But how can you join the data between these two tables? Is it possible? No, it's not possible because the connection to the source system is actually available during the different time periods. When you have the situation to join the table from both the source systems, since it is not possible, since it is not possible here to join the data, we need the staging area for that. So staging area is nothing but it's a temporary reason for loading the data. Temporary data. Only the temporary data will be storing here. Okay. So once you have, so you can join the data here. You can apply different transformation logic, and you can load the data into the OLAP system because the data is present in our end now. Okay, the data is present in our end, so that you can do applying different transformation logics here. Is it clear?
Okay.
So it is always mandatory to have the staging area because the source systems for extraction they are present in different time zones, and you may have to you may have in the present situation to join the data from two different two tables that are present in two different systems. Okay, which is not possible when you don't have the staging area. Okay, so the staging area is the mandatory region that you have it in the data warehouse architecture. It's every project will have the staging area. Every project will have the staging area. Okay, so all the raw information is present in this staging area, and it is a separate process. It's a separate database, or it could be a separate schema that you have it in the data warehouse. Okay, so when you talk about the ETL process here, so ETL process is basically it contains three processes. One is a data extraction, data transformation, and data loading. So when I say data extraction, it's nothing but it's a process of extracting the data. Okay, the data transformation is nothing but process of transforming the data, and the data loading is nothing but process of loading the data. Okay, so when I say data extraction, here it is two types. One is initial extract and incremental extract. So incremental extract or delta. So we call it as delta extract. So initial extract or full extract means that, so when you are extracting the data from the source system for the very first time, it's known as an initial extract. Means that what you do, so let us say you have some 10 million records in your source systems. Okay, for the first time you are extracting the data from the source system. Extracting the 10 million records is nothing but a initial extract or a full extract. So let us say on the day 2, out of this 10 million records, 2 million records are changed. 2 million records are changed. Means that 2 million records are updated in this source system. Okay, so you still have 10 million records in the source system, but 2 million records are changed. Okay, So instead of extracting the whole 10 million records and processing into the warehouse, you have to extract only this 2 million records which is changed. Okay. So this concept of extracting only the changed records from the source is what you call it as a incremental extract or the delta extract, which is called as a change data capture. Change data capture. Change data capture is nothing but capturing only the incremental information or capturing only the delta information that you have will be, yes, it is called as a change data capture or the incremental data extract. Okay. So when you talk about the data transformation, so data transformation is nothing but you're transforming the data. So when you're transforming the data, there are different ways how you transform the data. So you perform the data scrubbing, you perform data aggregation, you perform data merging, and you data cleansing. Okay. So when I say data scrubbing, it's nothing but it's a process of creating new attributes. Creating the new attributes. Okay. So when I say creating the new attributes, let us say you have an employee table, you have an employee number, employee name, job, and salary. So these are the 4 ports that we have it in the employee table. Okay. So you have a target. Okay. So let me show it in a brief. Okay. So you have the employee table here. So this contains all this information. Okay. And you have a target table called as employee underscore TGT, let us say. Okay. So this contains employee number, email, job, salary, and you have total salary or annual salary. Let's say annual salary is there. So this is the target table that you have it. So when you understand here, the annual salary is not present in the employee table in the source. So how do you calculate this annual salary? So the time you are transforming the data, yes, the time you are transforming the data, what you do is that you are going to extract a new, yes, you are going to extract a new one. You are going to extract a new column here, the time you transform the data, called as annual salary, and you make it as salary into 1. And you load it into the target. So what you are doing here, you are extracting the information, you are transforming the information, and you are loading the information to the target. And you are loading the information to the target that we have it. Is it clear? So the time you transform the data, you are actually creating the new ports based on the available ports. So salary is the port that is available. So based on the salary port, you are actually, yes, based on the salary port, you are actually calculating the annual salary. So creating of the new attributes based on the available attributes, this kind of functionality is called as a data scrubbing operation. Yes, this kind of functionality is called as a data scrubbing. Okay. So when you talk about the data aggregation, so when you have the data aggregation, so data aggregation is something which is nothing but, so let us say if you have a column called as, so let us say if you have a column called as sum of salary, sum salary. It's nothing but you are aggregating, you have to aggregate the information. So the time you transform the data, what you do, you will create again a column called as sum salary and you perform the aggregation of that salary column. So which is nothing but performing the data aggregation, which is called as a data aggregation. So you are summarizing the information and you are loading the data into the target. So the time how you are summarizing the information at the transformation level, you are summarizing the information and you are loading the data into the target. Okay. So the next one that you have it is that it's a data merging. So when I say data merging, it's nothing but it's a process of adding the, it's a process of merging the data. It's a process of joining the data. So if you have the same, so let us say you have the same table. You have a table called as employee that is coming from another application also with the same column. So what you do, you are going to just join the data. You are going to join the data between the two tables and you load it into the target. So this process is nothing but a data joining. So if you have some, let us say you have 100 rows here and you have 90 rows here. So since you have the same metadata here, what you do, you perform the union operation or union all and you load it into the target, which is the 190 records. You are merging the data and you are loading the data into the target. Okay. So this process is called as a data merging. So the another process is called as data cleansing. So let us say if your source is containing some missing information or missing data is present or the duplicate data is present or some kind of null values are present. So at the transformation level, you are going to just eliminate all those things and you load it into the target. So this process is called as a data cleansing operation. Okay. So it is not required for every ETL process you need to do all these things. Only for, only depending upon the situation or the requirement, we may use any of these operations in order to perform the ETL process. So once you have done the transformation, you are going to load the data into the target, which is called as a data loading. So this is called as the ETL process. So for doing the ETL process, you need three objects are mandatory. One is the source, another one is a target, another one is transformation logic. Source, you need to have the source, you need to have a transformation logic, and you need the target. But this transformation logic is something optional, means not for every ETL process we use this transformation logic. So if you observe this staging area, so you are not using any transformation logic. You just extract the information and you load the information into the staging area. Okay. So basically, these OLTP systems are present on the these are the transactional systems. So the time you extract the information from here, it is going to take a lot of time. It is going to take a lot of time while you are extracting the data from these OLTPs. But if you apply the transformation logic here, okay, so it will take some more time to transform the data in the Informatica memory. Okay, so that is the reason you are not going to do any kind of transformation. You are not going to apply any kind of transformation logic here, and you load directly the data into the data staging area tables. Okay, so this is what you have it. So this is the ETL process. So ETL process contains data extraction, transformation, and loading. And the objects that we need is that we need the source system, we need the target system, and the transformation logic, which is nothing but transforming the data into a format. So any questions so far? Any questions?
Venkat, how do we know which records are changed and which has to be extracted? How do we identify that and extract it to staging area?
See, that we will understand that. So when you start Informatica, you will understand how to get the records and what strategies we have to apply to get the records. We'll try to understand.
Okay.
Okay. Right. So that's what. So we have different transformation techniques are there where you have to apply to extract only the incremental information or which data you have to extract. How do you validate the data? Yes. So all those things we'll try to understand. We'll try to understand in the further classes. Okay. Right. So first of all, we load the data into the, we load the data into the staging area. So how frequently you are going to load the data into the staging area is that it may be, it depends upon the requirement. We may load the data daily, we may load the data weekly, and we may load the data monthly. So it depends upon the requirement again, how frequently you load the data. So all these jobs, so when you are extracting the data from the employee table and you are loading the data into the employee underscore STG table, it's nothing but a ETL job. Okay, so all these ETL jobs, okay, how frequently you do that is depending upon the requirement, and you are going to schedule that. You are going to schedule that in order to run according to the frequency that you set it there. Okay, according to the frequency, whether it is daily job, you will schedule it daily. Whether it is a weekly job, on which days you wanted to run it, you are going to schedule it. Okay, so you will be having some scheduling tools, third-party scheduling tools are there. So where you are going to schedule the ETL jobs in order to run them. So we are not going to manually run the ETL jobs. So all the jobs will be scheduled. So once we move the data into the staging area, so sometimes in some architectures we load the data directly into the OLAP system by applying different transformation logics. Sometimes in some projects, from the data staging area, we move the data into the optional region called as a ODS region. So ODS region or the ODS area, it's an optional area. Optional area. So what is this ODS area? So ODS is nothing but, first of all, it's an operational data store. It's an operational data store where you have the subject oriented data, you have the integrated data, you have the current data, current valued data is present here. Okay, so when you have the data of this importance, so this ODS area is something which is required for the operational reporting. So you can perform the reporting on the ODS area. So when you wanted to perform any ad hoc reporting, then you can do it on the ODS area. So what you do, you are going to apply different transformation techniques here. Okay, you will apply different transformation techniques, different error handling techniques. And here you are going to use the ETL process. So here you use the same ETL process, but you extract the information from the staging area, you transform the data, you apply different transformation logics, and you load the data into the ODS area. So ODS area, when I say ODS area, so it could be a separate database or it could be a separate schema that exists in the RDBMS. Okay, so here, for example, the table that we have is employee underscore ODS table, or you can it could be like ODS underscore employee also. Okay, you can recognize the tables like this. Okay, so from the data staging area, you are going to load the data into the ODS area. So when I say ODS area and the data staging area, they are not part of the ETL process. They are physical, means that they are the separate schemas or the databases that we have it in the real time. Okay, so ODS is again a database or a schema that contains the integrated data, that contains the subject oriented data, and they having, so when you have the data of such properties, so it will be useful for the operational reporting or the ad hoc reporting. So, and again, it's not a mandatory. So every project may not contain the ODS area, or the every project may not contain this ODS area. Every project will not contain. Okay, so only the projects which require, when the business user is required to have, when the business user is required to have the operational reporting, then he is going to ask for the ODS region. He is going to ask for the ODS region. So you may getting the doubt like, why exactly we need the ODS area? So why the client requires the ODS? What is the importance of that? Okay, so let us say if we have a requirement like you wanted to understand, I mean the client wanted to understand what is the current trends. What is the current trend, and you wanted to know the detailed data, how it is there. So if you don't have the ODS layer, so let us say if you have an order table present in the source, let us say you have a order table. Okay, so this table is present in the OLTP which contains all the order information. So, and my reporting requirement at this point is that my business user is interested to identify the monthly revenue. So I have the integrated data and it is loaded into a table called as, so let us say in the fact table, I mean in the OLAP table, the data will be present in the dimension table or the fact table. Okay, the data that is present in the OLTP systems will be in the dimension table and it is present in the fact tables. So dimension tables and the fact tables are present in the OLAP system. Okay, so let us say I have a fact table called as sales monthly fact table, which contains all the aggregated information that is done at the monthly level. Okay, so now in future again he comes back and asks about the detailed level information. The client has now asked about the detailed level information. So in my OLAP system there is no detailed level data. It contains all the aggregated data. Okay, so the data is aggregated according to the monthly level. The data is organized in this table. You cannot do it reporting. You cannot do the reporting on the OLTP system because it contains raw information. It's not actually fine tuned. So where do you have this information then? So you have all the current value detailed information only in the ODS layer. Okay, so in this case ODS layer will maintain the detailed level data, and from this detailed level data you can build a report on that, whether it is a weekly report or it could be a daily report. You can do that. So another advantage is that if you have to understand the current trends, basically sometimes business users will be having they are going to ask you about the ad hoc reports. Means that since you do not have the detailed information in the OLAP system, they wanted to understand what is the revenue growth in the last 30 days. What is the revenue growth that you have in the last 30 days? Then they will run some ad hoc reports or the temporary report that we have on the ODS tables, and they will give you the complete, the ODS region will give you the complete picture of the revenue, how it is growing in the last 30 days. So in order to understand the current trends, where you can do that? Only by using the ODS layer you can understand that. Okay, so from the ODS layer you're going to segregate, you're going to summarize the information. Yes, you will summarize the information, and you will aggregate the information, and you load it into the tables that you have it in the OLAP system. So what are the tables that you have it in the OLAP system? One is the dimension table, another one is the fact table. So you have the data summarized at the different levels. So weekly fact, sales daily fact, means you have you're summarizing that into different levels. Okay, daily level you are summarizing, monthly level you are summarizing, and weekly level you are summarizing the information. Okay, so this fact tables in the OLAP system basically it contains the summarized information. So likewise. Okay, so from the ODS area you can perform the reporting. Okay, from the OLAP system also you can perform the reporting. So this is the BA layer or the reporting layer. BA layer or the reporting layer. Okay, so from the OLAP system, so let us say, so when I say OLAP, so it is nothing but enterprise data warehouse. So enterprise data warehouse basically contains the information about the sales. It contains the information about the sales. It contains information about the finance. It contains information about operations, HR. So it contains the information about all the subject areas. Okay, but depending upon the reporting requirements, we may further denormalize this enterprise data warehouse into data mart. We are going to further denormalize them into the data marts, and we do that so. We'll build the data mart for sales. We'll build the data mart for finance. We'll build the data marts from HR. Okay. Based on the reporting requirements, we will further denormalize the enterprise data warehouse into the data marts. So once the data is present in the data mart, so let us say if I am the sales business manager, I wanted to understand the sales report. So what I'll do, so what I'll ask, so the BA developer is going to develop the report based on the sales data mart that is present here. Okay. So let us say, why do we have this data mart concept? Why do we have this data mart concept? Because let us say in your project there are some 100 business users are there. So 100 business users are there, and they are demanding a different business report on the data warehouse. So some want a sales related report, some want HR related, some want the reports related on both sales and finance. Okay, some want HR reports, some want different types of reporting authorities are there. I mean, reporting managers are there, which basically they are interested to understand the different reports. So when each time these many business users are there, for all these business users satisfaction, we have to build the reports only on the enterprise data warehouse. So when those many queries when those many reports are firing on this single database, it is going to affect the performance of the database here, which is one of the disadvantages that we have it here. So when more number of reports are built on a single database, it is going to affect the performance. So that is the reason what we do is that we are going to build a separate data marts for that. So once the data warehouse is constructed, so from the data warehouse, we'll load the data into the data marts, where it contains only the subject related information. So when you have a subject called as sales, it contains only the sales related data. So you can, if I am the sales business user, so I can directly query the data from this sales data mart in order to understand the sales reports. Okay. So in order to understand, satisfy the reporting requirements of different business users, so we are going to denormalize the data, and we design the data marts. So data marts are something designed on a specific department. So that could be a sales department, operation department, finance department, like that. So we build a data mart for each business unit. So the data mart is like a data warehouse, but it is limited to a specific subject area. So basically the end user will be highly beneficial because the report generation will be very quicker when it compares to the enterprise data warehouse. So instead of 100 reports building on the same database, if the reports are segregated, so for all the sales users, you can use this particular data mart. For all the finance users, you can use this different data mart. So you are actually segregating the business users according to the business requirements here. So which will basically increase the performance of the reporting solution. So if everyone is firing on the same database, for generating the reports, it will take a lot of time. So that is the reason you go for the data mart. So again, in all cases, you do not go for the data mart. Okay. So only when your data warehouse is very big and your number of business users are more, then the data warehouse performance also decreases. Okay, when you have more number of business users. So if you have more number of data and more number of business users are there, so you can organize your data into multiple subject areas, and you can distribute the business users according to the subject area that you have it, and you can build the data mart. Okay, so when you have the data mart, so all the sales business users will hit only the sales data mart. all the finance business users, they will hit only this finance data mart. Okay, so this is how you can basically perform a reporting on the ODS region. You can perform a reporting on the enterprise data warehouse, and you can perform a reporting on the data marts that we have it. Okay, so any questions so far? Any questions?
Venkat, the data mart, is that like a different schema in the same database?
Exactly, correct. So it could be again a schema, or it could be a separate database also.
Okay, so basically the information would be present at both the places, like in the enterprise data warehouse as well as the data mart. Like, am I understanding it right?
So information is same, but you have the data organized at different levels here. Okay, so you have so based on the reporting requirements. So if you have a more number of business users, then you segregate the information into the data marts here.
So basically, it's kind of a cut paste and not a copy paste.
No, it's not a cut paste. So you still have the information in the enterprise data warehouse.
Okay. So
you still have the interface.
It'll reside at both the places. So where basically it's a redundancy of the data.
Correct.
Kind of.
Correct. See, what I do is that, suppose, let us say, for example, I have two tables, like marketing table is there.
Okay.
And I have a sales table. Sales table and the marketing table is there in the enterprise data warehouse. Okay. So if the marketing user wanted to analyze the data, so what happens? If I'm running a campaign, that campaign is generating. If I wanted to understand how much how much sales revenue does the campaign is generating, basically marketing data is present in the marketing table. Revenue data is present in this sales table. Okay, but the business user is interested in data, so which is the combination of both this marketing and the sales table, because campaigning information is present here, and the sales revenue information is present in this table. So what I do, if my business user is interested in data which is a combination of both the tables, what I do is that I'm going to keep both the tables into a single table, which is nothing but a data mart. I'll keep this, I'll integrate the data that you have in both the tables into a single table, and I keep it in a.
Okay, so there would be some sort of an ETL involved when we, move the information from the either enterprise data warehouse to the data mart, correct?
Yes. See, it could be a ETL process. It could be done from a procedure. It could be done from a trigger. Yes, it could be done from any of the process.
Okay, got it.
Right. So, so that is the reason why we have the data marts. So, where we design one more table. If we want to design one more table, okay, based on the available data, where the reporting will be done on that particular table, then we'll use the data mart there. So, let us say this is the T3 table. Which is the combination of this marketing and the sales table. Okay, so this data mart basically it's a combination of marketing and the sales table according to the business user, because I cannot basically retrieve the report from the two different tables that I have, which is basically degrade the performance. Okay, so that is the reason I'll use the data marts. But these data marts are not mandatory, really, but not mandatory. So depending upon the requirement, we create these data marts. The architecture will have the data marts. When do you have the data marts? Only when you have a big data warehouse and the more number of business users are there. Okay, then you require the data marts. If not, it is not mandatory. Okay, but you have different kinds of architectures are present. So this is the typical architecture of the data warehouse. So you have like so you have these are the sources you have. This is the data warehouse. You use the OLAP tools to extract the data from here, and you load it to the and you are going to load it into the report. Okay, so report will show you the analysis. But so what do? You will be having your feed systems, which is nothing but OLTPs. You will extract the information. I mean, where all the business transactions are stored. You will extract the information, which is nothing but data capturing, which is nothing but a data extraction. So data extraction has two phases. One is the initial extract, another one is a incremental extract. Okay, and so once you extract the data, you load it into the data staging area. So from the data staging area, if it is required, you will load it into the operational data store. If not, you will directly load the data into the from the ODS region. You will directly load it into a data warehouse at the different levels, at weekly level, at monthly level. You summarize the information at different levels. Okay, at monthly level, at yearly level, you are going to summarize. Okay, so you have different architectures in the data warehouse. There are different architectures that exist in the data warehouse. Like so if you see here, so this is the virtual data warehouse. Means that, so virtual data warehouse is nothing but we are not building any kind of physical data warehouse here. So it is just we are reporting on top of the OLTP applications. We are performing the reporting on top of the OLTP application. So you are not building any warehouse here. There is nothing called as the ETL process involved in building this kind of architecture. No ETL process is required. So your OLTP itself is acting as a warehouse. So this is called as a virtual data warehouse. Okay. So this kind of architecture is something that is done for the small scale reporting solutions. Okay, where you do not need any historical analysis. Okay, when your business do not require any historical analysis, and you do not require any reporting on the historical trends, then you are going to then you can go for this virtual data warehouse architecture. Okay, so virtual data warehouse architecture is something that is done on the OLTP systems based on the current trends. Based on only the current trends, we have it. Okay, so you have some other kind of architecture called as a enterprise data warehouse architecture. So this enterprise data warehouse architecture is something which is widely used across many projects. Okay, widely used across many projects. So this enterprise data warehouse architecture will have the staging area. Okay, it will have the, I mean, if project demands, it will have the ODS region, and we load the data into the single database which acts as a data warehouse. Only a single database is present. Okay, only a single database is present where it contains the data. I mean, all the sales related information will have it in the sales schema. All the finance related information will have it in the finance schema. So likewise, you will have the, so when you have the data is less, like when you have the data approximately at 500 GB, okay, approximately at 500 GB, and you have less business users, then you can go for the enterprise data warehouse solution. Okay, you will have a single database here. So when it comes to the multi-tied architecture, see here, so you can see here, so we have the data warehouse, data is loaded, and the data is aggregated across multiple data marts here, multiple data marts. Okay, so multi-tied data warehouse. So from the data warehouse, we load the data into the data marts. So this kind of approach is called as a top-down approach. So when I say top-down approach, means that you load the data first into the data warehouse. After that, you load the information into the data marts. So since the data mart is dependent upon the data warehouse, so this data mart is called as a dependent data mart, and this kind of theory is called as a top-down approach proposed by Bill Immon. Okay, so Bill Immon has proposed this top-down approach where he says that, so it is always, it's a kind of traditional model that we have where the data first has to be loaded into the data warehouse. After that, it should be loaded into the data mart. Okay, And we have another kind of approach called as bottom-up approach. So in this bottom-up approach, first you are going to load the data into the data mart. Yes, you are going to load the data into the data mart. So depending upon the requirement, you may again create the data warehouse upon the data that you have it in the data mart. So here what you do, first of all, you will create a data mart for sales. Okay, I mean, depending upon the different modules, you will create the data mart. First you create the data mart for sales, after that you create the data mart for finance, after that you create the data mart for marketing. Likewise, you create the data mart sequentially. Okay, so sequentially you will create the data mart. If it is required, you are going to create the data warehouse from all the data marts. So this kind of architecture is called as a bottom-up approach. This is proposed by Ralph Kimball. So since the data marts are created independently, so this kind of data mart is called as a independent data mart. Okay, so this approach is called as a bottom-up approach. First the data marts are created, so if it is required, the data will be moved from data mart to the data warehouse. Okay, so when I say API, so application interface, it's nothing but it's a reporting. So you can report, you can perform reporting both on the data warehouse as well as the data marts. Okay, so for all the for every data warehouse architecture, we will have the data staging area and the optional ODS area will be present. Okay, so this is the different kinds of architecture that you have, and you have the data in a different levels. A highly summarized level, which is nothing but it's the data will be aggregated at the yearly level. Here, when it is lightly summarized, the data will be aggregated at the monthly level, and when it is current detailed data, the data will be aggregated at the detail level information. Okay, and this is how you have it. Okay, you can see the example here. Monthly sales by product for year, weekly sales product for the year, and the daily sales product for the year. Okay, so this is how you have the information in the data warehouse. Okay, so the data warehouse is contains two kinds of tables. One is a dimension table and the fact table that we have it. Okay, so any questions so far?
Hey Venkat, how do we decide which app to use, bottom up or top down?
See, we are not going to decide that, but you have a architecture. I mean, data architect is a position whom they are going to consult with the business users. So based upon the data that exists in the source system, right? They are going to design the architecture of the data warehouse. We are not going to do that.
Okay.
So again, it totally depends upon the amount of data that you have. Only depending upon the amount of data. See, when you have big clients like a Target or the Walmart, so they basically have very more. I mean, huge amount of data will be. Their transactions are more. Okay, like the HSBC Bank or the CT Bank, so they have more number of transactions. Okay, so at that time they may go for the top-down approach or either the bottom-up approach. Okay, so when you have the large scale clients like Walmart or Target or any other retail clients, so they will have a huge amount of data. So at that time they will go for either bottom-up approach or the top-down approach. Okay, so depending upon the time constraints and the delivery constraints, so they are going to have the architecture. Okay, so top-down approach or the bottom-up approach. So they basically it's a traditional architecture that we have. So which is going to take a lot of time for designing this kind of architecture. Okay, and when it comes to the mid-range clients like any kind of telecom industry or a banking industry, so which has a medium amount of data like 500 GB, around 500 GB, so they will go for the enterprise data warehouse architecture where we will have the single database. Okay, so where you have the single database in that. Okay, so it totally depends upon the amount of data that you have. They'll design the architecture.
Okay.
Right?
Okay. And what is that metadata?
See, metadata repository is nothing but it contains all the so when you are building the ETL, the details of the ETL will be present in this metadata repository. The details of the ETL. So what is the source table name? What is the target table name? What is the ETL process that we have different? All those things will be present in the metadata repository. Okay. So repository is nothing but it's a database where it contains the metadata related to the ETL process. Okay.